exploring the hidden limitations of crypto block space. Ever sent some crypto and watched in frustration as it took forever to arrive? Or worse, got slapped with a fee that was a huge chunk of what you sent? If so, you've slammed headfirst into a hidden limitation that exists in every single cryptocurrency, from Bitcoin to the latest meme coin. It's a digital traffic jam called block space, and it dictates the speed and cost of every transaction. In this video, we're going to uncover what block space is, why it's so scarce, and how this one concept might be the single biggest obstacle to crypto's dream of being used by everyone, everywhere. See, this isn't just a tech problem, it's an economic one. It's the invisible wall that decides if you pay $5 or $50 to use the network. It's the bottleneck that limits Bitcoin's base layer to processing only about 7 transactions per second, while a system like Visa handles thousands. Understanding this limitation is the key to figuring out where crypto is headed next. So, what is this digital real estate, and why isn't there more of it? To get our heads around block space, let's use a simple analogy. Think of a blockchain as a public ledger, but instead of one giant book, it's a chain of digital pages. Each new page is a block, and it can only hold a certain number of transactions. Block space is just the finite amount of room on that page. For Bitcoin, a new block is added roughly every 10 minutes. Originally, that block had a strict 1 megabyte size limit. Ethereum is a little different. A new block gets added every 12 seconds or so, and, instead of a fixed size, it has a limit on the total computational effort it can contain, measured in gas. But why have these limits at all? Why not just make the pages infinitely large? The answer is the single most important word in crypto: decentralization. For a blockchain to be secure, thousands of computers called nodes all over the world have to keep a full copy of the entire ledger. They all need to download, check, and store every new block. If blocks were massive, only corporations with huge expensive data centers could afford to run a node. The network would centralize, controlled by a handful of big players, and the whole point of a decentralized currency would be gone. So, this limit, this finite block space, is a deliberate trade-off. It's a choice to put security and decentralization above raw speed. But that choice has huge consequences. It creates digital scarcity. With only so much room in each block, when more people want in than there is space, you get a traffic jam. And just like in the real world, cutting through that traffic is going to cost you. This is where things get interesting because it creates what's called a fee market. Imagine every transaction waiting to get into the next block is in a big digital waiting room called the mempool. When it's time to build a new block, the miners or validators act like bouncers at the world's most exclusive club. They look at all the transactions waiting and decide who gets in. How do they choose? Easy. They pick the ones offering the biggest tip, in this case, the highest transaction fee. This creates a constant, real-time auction for block space. If you need your transaction to go through fast, you have to outbid everyone else. On a slow day, fees can be pennies. But when things get crazy, like during a bull market, a popular NFT launch, or the rise of new token standards, the competition gets fierce. We've seen this play out over and over. During the 2017 bull run, Bitcoin fees shot up to over $50 for a single transaction. More recently, in April 2024, the Bitcoin halving coincided with the launch of a new token standard called Runes, causing a frenzy that sent the average fee soaring to a record high of over $128. On Ethereum, a simple token swap that might cost a few dollars on a normal day could suddenly demand over $100 when the network gets congested. This auction system creates a massive roadblock for mass adoption. How can a network be a global payment system if sending a small amount of money costs more than the payment itself? It prices out regular users and entire categories of use, like micropayments or buying a coffee. This fierce competition for a fundamentally limited resource is the heart of crypto's greatest challenge: scalability. This tension around block space is so fundamental, it actually led to crypto's first great civil war. From 2015 to 2017, the Bitcoin community tore itself apart in a conflict known as the block size wars. As Bitcoin got more popular, that 1 MB block size was becoming a serious bottleneck. Fees were rising, and transactions were getting stuck for hours. Two factions emerged. On one side, the big blockers argued for a simple solution: just increase the block size limit with a hard fork. Their goal was to make Bitcoin cheap and fast, ready for global payments. On the other side were the small blockers. They warned that a simple increase would make it too expensive for everyday people to run their own nodes, which would lead to centralization and destroy Bitcoin's core value. They believed scalability had to be achieved in other ways, without changing the base rules. The debate was furious, spanning years of intense arguments and philosophical divides. In the end, the small blocker won out on the main Bitcoin network. Instead of a straightforward hard fork to increase the size, they implemented a clever soft fork upgrade called Segregated Witness, or SegWit. SegWit restructured transaction data and replaced the 1 MB size limit with a 4 million weight unit limit. This effectively increased the block capacity, allowing for blocks realistically up to 2 MB and theoretically up to 4 MB, all without forcing everyone to upgrade. The big blockers, however, didn't see this as a true solution. In 2017, they initiated their own hard fork, splitting the network to create Bitcoin Cash, a new version of Bitcoin with a much larger block size. This split was a monumental event. It proved that block space wasn't just a technical setting, it was a deeply political and ideological issue, powerful enough to fracture the biggest crypto in the world. Section 4. The Solution, Oz. The Quest for More Space. If fighting over how wide to make the main highway leads to a civil war, how do you solve the traffic problem? The answer the crypto world has settled on is this: you don't widen the highway, you build new roads on top of it. Welcome to the era of Layer 2 scaling solutions. The idea is to move most transactions off the congested main chain, Layer 1, and onto a separate, faster layer. These Layer 2 networks can process thousands of transactions for a fraction of the cost. They then bundle, or roll up, all of those transactions into a single, compressed package that gets sent back to the ultra-secure Layer 1. It's like a carpool lane for crypto. Instead of thousands of individual cars clogging the road, one bus carries everyone efficiently. For Bitcoin, the best-known Layer 2 is the Lightning Network. It's designed for instant, nearly free transactions, making it perfect for the kind of small everyday payments that are impractical on the main chain. For Ethereum, the winning solutions are called roll-ups. Projects like Arbitrum, Optimism, and ZK Sync act as their own fast chains that post their transaction data back to Ethereum for security. This strategy got a massive boost in March 2024 with Ethereum's Denkun upgrade. The upgrade introduced blobs, a new and much cheaper way for Layer 2s to post their data. The impact was revolutionary, slashing transaction costs on these rollups by over 90% in many cases, and making them dramatically more usable. These Layer 2 solutions are where all the action is right now. They represent a huge strategic shift. Keep the main blockchain decentralized and secure at all costs, and build scalable layers on top. It adds some complexity, but it's the most promising path we have to solving the block space problem without sacrificing what makes blockchains so special in the first place. This world of Layer 2s, rollups, and the Denkun upgrade is a rabbit hole of its own, and the introduction of blobs has totally rewritten the rules for scaling Ethereum. If you want to understand how these solutions are changing the game and what it means for the future of transaction fees, you'll want to check out our next video on that exact topic. So, block space isn't a bug, it's a feature. It's the fundamental trade-off at the core of every decentralized network, balancing the constant tug-of-war between speed, security, and decentralization. The digital traffic jams and the crazy fees are a direct result of that deliberate compromise. For years, this limit was seen as crypto's fatal flaw, the wall that would stop it from ever competing with traditional finance. But the pressure it created has sparked a wave of incredible innovation. From the philosophical battles of the block size wars to the brilliant engineering of Layer 2 rollups and the Lightning Network, the struggle for more space is what's pushing this industry forward. With the approval of Bitcoin ETFs, bringing a flood of new interest, the pressure on these networks is higher than ever. The race to scale is on. Understanding the invisible walls of block space is the first step to seeing where this technology is truly going. The future of crypto won't be built by ignoring this limitation, but by finding ever more creative ways to build it.